We're going to go ahead and finish Unit 5 Progress Check Part A by doing 9 through 12. So number 9, let f be the function defined by that equation there from 0 to 3, which the following statements is true. And it looks like we're talking about f increasing or decreasing. And so the way we can learn about f increasing or decreasing is by figuring out what the derivative is, because if the derivative is negative, f is decreasing. If the derivative of f is positive, then f is increasing. So what we're going to do is we're going to find when is the derivative 0. We're going to use a little sign chart to figure out, once we know it's 0, on what intervals is it increasing or decreasing. So let's find the derivative. Derivative is 3x squared minus 12x plus 9. We want to set that equal to 0. And at the same time, we see that 3 goes into all those, so we'll divide everything by 3. And then we can factor, and we see that the derivative will equal 0 at 1 and 3. And so we'll make a little sign table over here. We have 1, we have 3. We know the derivative is 0 at those spots, so let's pick the intervals. So something to the left of 1, 0 is to the left of 1. So we'll put 0 into our derivative, which gives us 9. That's positive. We can put 2 into our derivative, so that's 3 times 2 squared minus 12 times 2 plus 9. That's 12 minus 24 is negative 12 plus 9 is negative 3. And that's actually all we need, because we're only asked about from 0 to 3, and so we're stopping at 3. And looks like it will be positive from negative infinity up to 1. So it will be increasing from negative infinity up to 1 and decreasing from 1 to 3. Well, we don't need positive infinity. We only need from 0. So it's increasing from 0 to 1. Because the first derivative is, this is wrong. So this would have to be a greater than sign. So that's not right. So it's not this one. It's increasing from 0 to 1, so that wasn't correct. It's decreasing from 0 to 2 because of the second derivative. Nope. Hopefully it's this one. F is decreasing from 1 to 3, which is what we found, because the derivative is less than 0. So the answer is D. Number 10, let f be the function defined by f of x equals x times the natural log of x for x greater than 0. On what open interval is f decreasing? So decreasing, again, the derivative. We want the derivative to be negative, and so let's find the derivative. So we have to use the product rule here. So we have x times 1 over x plus natural log of x times 1, which is just 1 plus natural log of x. We're going to do the same idea as number 9. We're going to set this equal to 0 and solve. So we'll subtract 1 from both sides. So negative 1 equals the natural log of x. Switching to exponential form, this is log base e. So we have e to the negative 1 is equal to x. That's when our derivative is equal to 0. Which is 1 over e. As we look at our answers, we see 1 over e there, not e to the negative 1. So we have 1 over e. So let's pick some values in here. 1 over e is a fraction. So let's just let's pick like 0.1. 0.1, or we could even pick, let's pick something to the right of it. Let's pick So let's pick 2. So picking 2 into our function, or into our derivative. I should have left it like this before. So this is 1 plus natural log of x. E to what power gives me 2. So that's going to be a negative, but a pretty small negative. So this is going to be positive. So it's going to be positive over here, negative over here. We could pick something like 0.1 and think through that. And so from when x is greater than 0, it will be decreasing. So we want it to be at 0 here, decreasing from 0 to 1 over e. 0 to 1 over e, so A. 11, let f be a function with first derivative given right there. At what values of x does f have a relative maximum? So relative maximums occur at critical points when the derivative is 0 or undefined. Here's the derivative here. This will never be undefined. So let's look at what makes it equal 0. Probably don't even need to write all of this. It will equal 0 at, let's put this in order, -1 because of this, 0 and 5. And we'll just do a sign chart again. So we have -1, 0, and 5. We're going to pick something in each interval. If we pick -2, so something over in this section, -2 would be -2 times -7 squared times -1, which will be positive. Again, we don't care about the number, we just need to know what the sign is. So this would be positive. Because what we're going to do is we're going to look at to the left and to the right of the zeros to see, we'll be using the first derivative test. I should have mentioned that before. So we know this is just kind of a little sketch of our graph. We know that the derivative is 0 at -1. I don't really know where this is vertically, so 0 there. So right now we know it's positive coming up to -1. Now let's find what's the slope from -1 to 0. So let's put in -half. So -half would give us, so putting it into our function here, would give us -half times -half minus 5 squared, and -half plus 1 would be 1/2. We see this is a negative because this is squared, it's positive times a positive, so this is negative. From 0 to 5, so let's just pick 2. Let's put a 2 into our derivative, which would be 2 times -3 squared times 3. That's going to be positive. And let's throw in like something like 10. And again, we only need signs here. So throwing in 10, we have a 10, which is positive, times 10 minus 5, which is positive, squared is still positive, and 10 plus 1 is 11, which is positive. So this is also positive. And so we want a relative maximum. Well, again, what I was mentioning here at -1, the derivative 0, the slope is positive, so the graph is increasing before it and negative after, which would make that a maximum. And then from at 0, it has a derivative of 0. It's negative, then 0, then positive. And then at 5, it's positive to the left of 5, 0 at 5, and then positive again after 5. So we see that we have a maximum at -1, a minimum at 0, and a point of inflection here. So we're only looking for maximum. So we have a relative maximum at -1. All right, and number 12, looking at this thing here, the graph of f prime, the derivative of the function f is shown from 0 to 9, which the following statements is true for x being between 0 and 9. So it looks like we're talking about, we have the derivative, we want to know about the function f. And it looks like it's talking about minimums and maximums. That's not even talking about points of inflection. So we know minimums occur when the derivative goes from, well, let's look at it. So if the slope is positive, and then the slope, so slope is positive means our function's moving up. Slope is negative means our function's moving down. So we have a positive slope, a slope of 0, and then a negative slope. So positive slope, 0, negative slope, that means it's a minimum. So when we go from positive to negative, it's a minimum. When we go from negative to positive, it's a maximum. So positive is above the x-axis. So positive to negative is a minimum. So this is a min. Negative to positive is a max. Positive to negative is a min. And negative to negative again is a point of inflection, which we're not concerned about. So we have 2 minimums and 1 maximum. So 2 minimums and 1 maximum. B is our answer for number 12.